In this video, I am discussing first 15 questions of Grand Test 7 Physics. Here, frequency of sonometer wire. So that is, let us write, which is 100 Hz. When the weights producing the tension are completely immersed in water becomes so weight producing wires when they completely immersed in water. So at that time, frequency of sonometer wire is 80 Hz when it is placed in water. When corresponding weights are placed in some liquid, then its frequency is 60 Hz. Now, basic thing here is in sonometer experiment, string is stretched between two fixed points. So whatever vibration is produced in the string, then its frequency in fundamental mode, we write 1 by L root of T by mu. So this is in fundamental mode. Actually, we here is this is lambda by 2, which is L, where lambda is 2L. So N is V by lambda, that is V by 2L. Velocity of a wave which generated in a string. Here mu is mass per unit length. So here we have loss of tension. So loss of tension means resonating length and mass per unit length are constant, then frequency will be only proportional to tension in the string. So mass anyhow it will not change, it is proportional to so G. In case so here weights are in air, this one, these weights are in liquid, there is an upthrust. So that net weight will be VdG. D is density of that object in air, density of water in G, which is mass into original mass in air, volume into density mass acceleration. Acceleration is, so here it is, D stands for density of substance in air by density, or 1 minus dW by D of G. Now here I'll replace some space. In second case, because here question is F is directly proportional to root of acceleration. Here acceleration is nothing but I will write F1 by of water, your acceleration will be so F1 here is 100, Fw is 60, 1 by 1 minus dw by d. So root of 1 minus dw by d, reciprocal, that is 3 by 5. So 9 by 25, 16 by, so density here is, so this is one equation. Similarly, some other liquid instead of water, so there you get so here it is 100 by 60 is equal to 1 by under root 1 minus dl by d is equal to 9 by 25. dl by d is 16 by 20. So now here, technical word, what he asked, specific gravity of liquid. What is specific gravity of liquid? Basic definition, relative weight of liquid with respect to water. It is density of liquid by density of water. So from this 1 and 2, if I divide 2 by 1, dl dd get cancelled. dl by dw here is, what I am doing is second, I am dividing with first. So 25 get cancelled. One minute here, I made a mistake. 25, 3 by 5, 9 by 25, 16 by 25. Here it is 100 by 80, sorry. This is 4, 4. It is 16, so it will be 9. So density of liquid by density of water. So here 70 remains, roughly 7. So option is second one. So to find electric field form dimensional, so related formulas you try to remember. Force experienced by unit charge, ml t power minus 2 by charge is I into t. So ml t power minus 2 t power minus, or it is ml t power minus 3 a power minus. So magnetic field. Just remember the formulas. When a current is flowing through the loop, magnetic field will be this. From here, mu naught will be 2 Br by I. Once you know magnetic field, you can find permeability. So to find magnetic field dimensional formula, force here is current is in amperes. So here you have length m a power minus 1 t power. Now once you know dimensional formula for magnetic field for permeability m a power minus t power minus 2, current here is amperes. M a power minus 2. Yes. Now he is asking E square. E square by mu will be M square t power minus 6 a power minus 2 by mu naught will be M a power minus 2 t power minus 2 L. A power minus 2 get cancelled. So M L t power minus 4. So that is the dimensional formula for E square by mu. When switch is closed at T0, current flows through it, but current initially inductor opposes flow of current with infinite resistance when not always at time 0. So then potential difference will be here across these two terminals or across, let us say, AB, CD. Potential difference AB here becomes 12 volts, CD also 12 volts because they are parallel. Even though current is not flowing, EMF will be there induced in the across the inductor, that is 12 volts. Now as over a time of period, current passes through the inductor slowly. At one stage, there is no change of current. When there is no change in the current magnitude, no change in flux, no EMF induced. So a steady, that is called steady state, current passes through the inductor. It's like a simple wire. But meanwhile, at different timings, different amount of current is passing through it. So different potential difference exists across L. So that I is equal to I naught. How current changes, this is a derived one, LR circuit. So here EMF induced is minus L di by dt. From here, di by dt is minus I naught minus R by L. I naught R by L. So it is minus L into I naught R by L. I naught here is, so that is maximum current through it is 12 by 2, 6 amperes. Resistance is 2. R here is 2. L is 400 millihenries as a function of. So it is E minus 2 per 40. That is 12 e power minus 1 by 20. It is for 400 into 10 power minus 3, right? 20 by 4. T power minus 5. And through polarizer, unpolarized light, I naught is incident on polarizer. Its intensity decreases to half. And second polarizer is kept an angle theta. Then by Malus law, so the emerging beam intensity is this. That phi he given 45 degrees. You get I naught by 4. Here, power consumption always depends upon power factor, which is cos phi. Right. So here we know power formula, that is nothing but half V naught I naught cos phi. Here between current and applied potential difference, so omega t minus pi by 2. That means current is lagging voltage by pi by 2. That means phi here is pi by 2. Cos phi becomes 0. So power consumption is 0. Your photo cell is illuminated by bright source placed 1 meter away. Intensity of a source is inversely proportional to, so here is a source, here intensity. As distance increases, intensity decreases. How? By this one. Now initially 1 meter, now R becomes half. So intensity becomes 1 by 4. That is, intensity becomes 4 pi, 4 times. So once intensity increases, then number of electrons, intensity is nothing but more number of photons are incident on it. So proportionally electrons will emit by photocathode. So number of emitted electrons becomes 4 times initial. Intensity increases, number of emitted electrons will increase. So increases by factor 4. Here in this circuit, these three are in series. So here 8 ohms, here again 8 ohms. These two are in parallel. Effective becomes 4 ohms. That is R1 R2 by R1 plus R2, 64 by 16 ohms. Again that 4 ohms again 2 ohms. These two are in. Now here these are in series. If you redraw the circuit, here 8 ohms. So these two are in parallel. Here it is how much? 3 ohms, right? So 8, 8, 4 parallel, 4 plus 2, 7 plus 3, 10. So net resistance now current will be, what is the potential difference? 9 by 10. So 0.9 ampere current close to it. I think here I made a effective resistance 4 plus 3, 7 plus 2, 9 ohms. That is 1 ampere current flows through it. When 1 ampere current flows through it, so consider this circuit. Here it is. These two are in parallel. So resistance also equal. 8 ohms, 8 ohms. Current will be distributed equally. That means through this half ampere current flows. Through this also half ampere current. 1 ampere will be divided equally. So that means in 3 ohm resistor, here half ampere, right? 0.5 ampere current flows. Right. One ampere current. Here it is 8 and 8 ohms, 0.5 ampere current flows. Again, here is 8 ohms. Here 2, 8 ohms. 0.5 ampere current flows throughout the circuit 0.5, but this 8 ohms is obtained by So here 8 ohms. This 4 ohms is obtained by here 8, here 8. They are in fact parallel. Zero point 0.5 current ampere flows through it through each resistor. 0.25 ampere current flows through it. That means this 8 ohms is this. Through this 4 ohms, 0.25 ampere current flows. So in 3 ohm resistor, 0.25, 0.50 current, that seems to be two options paper. Here, once you project any object, at an angle theta, kinetic energy is same mass, only difference with a velocity. Kinetic energy is half m in place of u cos theta. So here, same mass means maybe velocity different. K1 is to K2, half mu1 square cos square theta, and a half mu2 square, which he given it as 4:2. That is u1 cos theta 1:2. So ratio of maximum heights, yes, he given it as 4:1. That means u1 sin theta 1 by, so the ratio of ranges will be, range has a formula u square sin 2 theta by or 2 times u sin theta u cos theta by, that is 2 ux uy by, now ux is this for one, for second one is u sin theta 2 by g. For first one u cos theta is 1. So answer is 4:1. Your body is projected from the ground. What is the ratio of constant? Equation of trajectory. So tan theta here is tan 30. That is A equal to, A is nothing but tan theta coefficient. Your B value is u square he given 20. So tan theta is 30, cos square 30, 3/4. G by 10 by 600. 1 by 60. So ratio of A is to B, that is 60 is to √3. 20 √3 is to 1. So equal current I flows in the segment. So let us divide equal currents. Now I'll choose ACB one path AD. In ACB path, current flows in clockwise direction. So then magnetic field will be inverse. In ADB path, current flows in anti-clockwise direction. So magnetic field will be outwards. Here inwards, here outwards. Net will be, we don't know which is more. So difference, be whatever it may be, which is more that we will consider. So magnetic field will be mu naught I dl sin theta by 4 pi r square. For us, if current passes through it, dl and I, in fact, we find angle between mu naught I dl sin theta r and dl. R is this, dl is this. That theta is 90. So in case of circular coil, theta is 90 by 4 pi r square. If it is total circle, integral dl will be circumference. But he said just arc, integral dl for one path is this. For AB path, arc length is r theta. So I'll calculate first B for ADB path, mu naught I, integral dl is for this path. For which path? This path. R theta. Here angle what we have chosen is theta. So in place of dl, it is dB in fact. So dB will be integral dl. Integral dl is r theta by 4 pi r square. That is mu naught I theta by 4 pi r. Right. Similarly, other angle if you consider, it will be 2 pi minus theta. So that is ACB path mu naught I by theta here is 2 pi minus theta by 4 pi r square. Cancel. Mu naught I 2 pi minus theta by, so taking the difference, theta theta get cancelled, 2 pi by 4 pi r. R in the sense he took radius of the loop as a, 2 pi 2 times you get mu naught I by 2a. Here it is angle also there, right? 2 pi minus theta minus theta. So I think the difference will be, sorry, it is not get cancelled out. It is 2 pi minus 2 theta we get. That is mu naught I pi minus theta by 2a pi. Suitable option, second option. Here, specific charge. Specific charge means basic definition, charge per unit mass. That is alpha equal to E by m. This charged particle on this charged particle, electric field applied and magnetic field also applied, but in some direction. So net will be force due to electric field. But here, force on magnetic field, right? Force on charged particle due to magnetic field. The work done by magnetic field is if B dot, that is Q V cross B, S and V are proportional, like V dot, here this becomes 0. So there is only work done is due to electric field. Work done only due to electric field. Now here, this particle force is applied, E naught, electric field is applied, work done by electric field is forced into some till where x naught displacement. The particle which is at rest, it gains a velocity this. So that velocity, he given it as 4i plus 3j. Magnitude will be 5. So Q by m Ex naught half into V square is 25. So she's asking x naught 25 m by 2 QE. That is Q by m is alpha. So 25 by 2 alpha E naught is the right value of x naught. Now here in this AC circuits, some circuits are series circuits, some are parallel. This is AC parallel circuit. So how these kind of circuits will be solved? In series, current is same. We take current along x-axis and voltage lagging or leading. We draw phasor diagram, we will do vector addition. In a parallel circuits, voltage is same. We take potential on x-axis. So in series circuit, you observed current if you take, so here inductance, the potential in pure inductor circuit, potential leads current by pi by 2. That means current lags potential by pi by 2. So this is due to inductor because current lags potential. In case of resistance, potential and R are in the same phase. In case of capacitor in a series circuit, current leads potential by I. So here it is. So here current leads means potential will be lagging. This is capacitor. Now peak current. So what is the current through this capacitor? Current will be V by XC through capacitor. XC he given it as 2R. Through this inductor V by impedance, that is. Here it is nothing but it's a reactance, inductive reactance. That XL is R. So I effective will be V by R minus V by 2R. If you simplify it, you get V by 2R. So here, which is dominating through this L. So the resultant one will be where it is R. So here potential is V. Here potential, your current is what? V by R, right? Through the resistor. So here effective is V by 2R. So net will be V square by R square plus V square by 4R square. So that is 4 plus 5V square by 4R square. Whatever he say V naught, he given maximum amplitude is V naught. You take all V naughts. Root 5 by 2 V naught by R. That is first option is correct. So in Young's double slit experiment, one of the slit is wider than other. One slit is double that of other intensity. IM be the maximum intensity. The resultant intensity is I1 plus I2 plus 2 root I1 I2 cos phi. One of the slit is wider. So wider means more intense. So that amplitude. So intensity is proportional to so amplitude is doubled. Intensity becomes 4 times. 4I1, 2 root I1, 4I1 plus 5I1 plus 4I1 cos phi. If you take I1, 4I1 common, 1 plus cos phi. 1 plus cos phi is So here, in fact, I1, IMB, the maximum intensity, the resulted when they interfere at a phase difference. Okay, here phase difference I have taken. So the resultant intensity I1 into 8 cos square phi by 2. So you get a maximum intensity when phase angle 0. That is IM here is 9I1. So the resultant is 1 plus 8 cos square phi by 2. So here radius of second orbit, the de Broglie wavelength. So 2 pi r is n lambda. So the radius of second orbit, he given r2, that is 2 lambda. R2 here is 2.116 angstroms. So lambda here is 5 into 2.116. Here it is 2, it is 3 roughly. Nearest one is 6.64 angstrom unit. Here, longest and shortest wavelength we can find by using this. So if any photon ejected from infinite orbit to ground state, so that will have more energy, less wavelength. So shortest wavelength is for shortest, or that is 1 by lambda least. So it's a Lyman series. N1 will be 1. So 1 by lambda L is RZ. For longest, so lambda must be longest means energy here is lambda is more means E must be less. That is 1 by 1 square minus, so second orbit to first orbit. It is longer, it is shortest. Let me write longest. This is RZ square 4 minus 1, 3 by 4. 1 by lambda S by 1 by lambda L. Get RZ square get cancelled. Is longest to shortest is 4 by 3.